So we are on page 16. So once again, we talked about the 45s and how they came to be, how they have coordinates of root 212, root 212. And now we're talking about the 30-degree angle. Okay, so 30-degree angles. I'm just going to focus on quadrant 1. 30-degree angles, 30 degrees is the radian measure that is equivalent to pi on 6. So how did that come to be? Well, 30 degrees, if I do my conversion, times pi over 180, right? To convert to radians, you can see 30 goes into 30 once, into 186 times, so it becomes pi on 6, right? So maybe the first thing we'll do is we'll just figure out what all the degree measures are, and I think I'll do that in a different color. So this is 30 degrees. What will the related angle be in quadrant 2? 30 degrees away from the x-axis? 150, right? 150 degrees. What about in quadrant 3? 30 degrees away, 210. And then 30 degrees away from 360, 330, right? And then this is 30 degrees. Okay. Now let's do our radian measure too. My radian measure is pi on 6. I could take these and convert to radian, but let's try and do it radian way. If this is pi on 6 away, I guess I could think of this as being pi, but if I think of this in terms of sixths, this would be 6/6 pi, right? This would be 1 full pi right here. My related angle is 1/6. So what will my radian measure of 150 be? What's equivalent to 150 degrees? 5/6, right? 5 pi on 6. 1/6 away from 6/6. Okay, what about down here? What will this one be called? 7/6. Excellent. Okay, and this is 1/6. And then this one, it's 1/6 away. What would a complete revolution be? 2 pi is equivalent to how many sixths? 12/6. Okay, so what will this guy be then? 11/6. All right. So these are your decimal equivalent, or your radian equivalents: 1/6, 5/6, 7/6, and 11/6. Okay, let's get the point coordinates though. The coordinates of the point. So what I need is, if this is my point, this is my point P, I need my x, y coordinate, okay? And then x and y, because this is the unit circle again, x and y are going to be my cos and my sine. So I take a look at this triangle, and I can see that it's, you know what, I should have, let me just see if I have my little eraser. I don't want that pi on 6 down here. I should have thinking ahead. My little eraser here. Okay. I'm just going to move my little, pi on 6 up here. Okay, so I have this triangle here, and if you look closely, it's a right angle triangle again, right? Because we're talking about right angle trig. So this angle is 90 degrees, right? And this is 30 degrees. And there's a geometry theorem that says, so I'm just going to tell this to you. Well, first of all, how big will this angle measure be? 60 degrees, right? 60 degrees. So there's a geometry theorem that states that, I'll just draw it down here. This is 30 degrees, this is 90 degrees. Oh, sorry, 60 degrees. Ay, ay, ay. Okay. In a 30, 60, 90 degree triangle, the length of the shortest side is exactly half of the hypotenuse. There's special triangles. The one we were talking about yesterday, the 45-degree triangle, was special because it was isosceles. And in a 30, 60, 90, it has special qualities too. The shortest leg, so there's always going to be a short leg and a long leg because the 30-degree angle is shorter than the 60, so the side associated with will be shorter than 60. So the shortest side is exactly half the hypotenuse. Well, in this case, the hypotenuse is 1, right? So if the hypotenuse is 1, that means this length is a half. And I'll call this is the side associated with y, right? The distance y. So we'll say y equals a half. And that's true for any 30, 60, 90 triangle. So all we have to do is find x. All right? So this is Pythagoras. Let's see if we can figure out what x is. X squared plus a half squared equals 1 squared. So x squared plus a quarter equals 1. So what will x squared be? X squared will be, well, it'll be 3/4 first, x squared, right? And now I'm going to square root. Okay, so then I get x equals the square root of 3/4, which is the square root of 3 over the square root of 4, which is, as John said, the square root of 3 over 2. Okay? So the length of x is the square root of 3 over 2. All right, so I have my cos and my y, right? So x equals the square root of 3 over 2. Y equals 1/2. So there are my coordinates of my point become root 3 on 2, 1/2. And that gives me my cos and my y, right? Sorry, my cos and my sine. So then we say, so cos of 30 degrees equals root 3 on 2. Sine of 30 degrees equals 1/2. We got to figure out what tan equals, right? This one's not so easy. So we remember tan equals y over x. So let's move down here again and find tan. Find tan of 30 degrees. Okay, tan of 30 degrees is going to equal y over x, or sine over cos. So let's see what that gives us. So I have 1/2 divided by root 3 on 2. So I'm dividing by fractions, right? Which means I end up multiplying by the reciprocal of a fraction. And we say tan equals 1 over root 3. And if I wanted to rationalize, which is what your textbook does, times by root 3 on root 3 would be root 3 over 3. Okay, so that's the last piece to the puzzle. Tan equals root 3 on 3. So that means if I go around the unit circle, these 3 values will be associated with each of the related angles. They're the same values. The only thing that changes is the plus or the minus sign, right? The positivity or negativity, depending on what quadrant. So in quadrant 2, cos is positive, sine is negative. In quadrant 3, both cos and sine are negative. Oh, sorry. Ay, ay, ay. I need to get my little, does anyone have that tape? That little white tape? Forgot one in the math office. Do you? Can I borrow some? I've made so many mistakes today. Thank you. Okay, sorry. Cos is negative. Sine is positive in quadrant 2. They're both negative in quadrant 3. In quadrant 4, cos positive, sine negative, right? So if we did this like we did yesterday, then I'll say tan of 150 equals negative root 3 on 3. Cos of 150 degrees equals negative root 3 on 2. And sine of 150 degrees equals positive 1/2. And 150 and 5 pi and 6 are the same thing. If I move down here, maybe I'll flip over to radian measure then. I could say that cos of 7 pi on 6 equals negative root 3 on 2. Sine of 7 pi on 6 equals negative 1/2. And tan of 7 pi on 6 equals positive root on 3. And then the last one, right? Cos of 11 pi on 6. Oops. Pi on 6 equals root 3 on 2. Sine of 11 pi on 6 equals, sorry, that's a negative, negative 1/2. And tan of 11 pi on 6 equals negative root 3 on 3. So there's a lot going on in these triangles, right, or in these circles. You have to know about related angles, the family of related angles. You have to be able to recognize the related angles in degree or in radian measure. And then you have to be able to eventually tell what the sine, cos, and tan are. So there's a lot to know in these, right? This is the building block on the memory work, because this is what you're going to use to solve trig equations without a calculator. Right? Okay, I'm going to let that sink in for a sec. Any questions at all? About how we derive these? Okay. So we're almost done. What do we know so far? We know so far we have our 45-degree angles, right? At 45 degrees, or pi on 4. We know that cos of 45, cos of the angle, sine of the angle, and tan of the angle. Right? So for our 45s, cos equals root 2 on 2, right? Sine equals root 2 on 2, and tan equals 1. And all you have to do is adjust for the positives or negatives according to the quadrant rule, right? Which other one did we learn? The one we learned today? We've got our 30-degree angles, right? Which is also known as pi on 6. Cos equal to root 3 on 2. Tan is 1/2. Or sorry, sine is 1/2, and tan is root 3 on 3. Okay? Did I? Oh, what is it, guys? Yeah. Yeah, it's 1 over root 3, right? Yeah. Root 3. Now, for the quadrantal angles, they're a little funny, right? And those are just the ones that you're going to have to, in some ways, just sort of memorize. And the way I memorize the quadrantals is I just say, oh, this point is 1, 0, this is 0, 1, negative 1, 0, 0, negative 1. And then I just remember that the first one is cos, right? The second value is sine. So cos and sine, and then tan just equals y over x, right? I just remember that the first partner's cos, first partner's sine. I think those are pretty easy to remember, right? You shouldn't have to memorize those ones. So the only other one you really have to memorize is 60 degrees. And you can see, I think, if you just have to memorize, and you shouldn't have to memorize tan, you should just have to figure out how to get tan, right? Tan is just the y over cos. You only have to memorize like four values, and these two values are the same. It's not really that much. And you only have to memorize these because these are your quadrant ones. The values stay the same no matter what quadrant you're in. It's just the positive and negative, right? So if you combine this info with what you know here, you'll be able to know any trig ratio for any of the special angles. And these are the only special angles that you're going to be required to know is the quadrantals, the 45s, the 30s, and then the 60s.
We don't really need to memorize the 60 because we have the 60.
But we don't know that yet. We haven't talked about that yet, right? Okay. So we got to do the last one. And then I'm going to give you a bit of time just to work a little bit, and then maybe we'll do some more examples in the second part. Okay, let's look here. This is the last family, the 60-degree family. So what is 60 degrees as a radian measure? 60 degrees times pi over 180. Cancel out. Pi over 3? Perfect. Okay, so let's do all our related angles first. So I have 60 degrees. So I'm going to record this again. This is 60 degrees. What's the related angle in quadrant 2? $60 degrees away from 180? 120? Okay, 60 degrees away from 180. Remember, this is 180. 240. And then 60 degrees away from a full circle. 300. Okay? All right, let's do our pi on 3s then. So this is also known as pi on 3. Okay, so if I'm thinking pi on 3s, I kind of have to think of this as not just pi, but not just 1 pi, but 3/3 pi, right? That's how I probably think of this guy. Okay, so he's 1/3 away from 3/3. What's 3/3 take away 1/3? 2/3, right? So 2/3 pi. Okay, what's 3/3 plus 1/3? 4/3. Okay, and then if I'm using thirds, 2 pi would be 6/3, right? Okay, so I'm 1/3 away from 6/3. What's 6/3 take away 1/3? Okay, so I got all my, those are my equivalent angle measures. Now let's take a look at this triangle. So what do we know about this triangle? This is 90, this is 30. What does this have to be? 30. And remember what we said about a 30, 60, 90 triangle? The shortest side is half the hypotenuse, so this length will be a half. Okay, it's the same triangle, just flipped on its side, right? So if this is a half, and I use Pythagoras again, this length will be √3/2, right? This is actually the same triangle, but instead of it being down low, it's just reoriented, right? We just took this triangle and flipped it and stood it up on its side. So the coordinates are the same, they're just flipped. It's like the inverse. So I know that the coordinates of this point are, this time x is a half, cos is a half, y is √3/2, or sine is √3/2. So here, I've got cos of 60 degrees sine of 60 degrees. So this equals 1/2. This equals root 3 on 2. And tan, I could just flip that guy, but let's figure out what tan is. I'm just going to move down here and I'll figure out what tan is down here. Tan of 60 degrees equals root 3 on 2 divided by 1/2. Because we ended up rationalizing that guy. So tan is just going to be equal to root 3. Okay? So that's kind of nice. Tan. You don't really have to memorize tan, to be honest, because you could always just calculate tan, right? I think. Okay, so there's your... So if I just transfer this over, this is going to be -1/2, positive root 3 on 2. Down here, it's going to be -1/2, negative root 3 on 2. And down here, positive 1/2, negative root 3 on 2. And once again, we've got then cos of 120, sine of 120, tan of 120. These two will be negative, right? Only sine stays positive. Right. And then just to complete our circle, the last two down here, I'll talk about in degree mode, so I'll say cos of 4 pi on 3, sine of 4 pi on 3, tan of 4 pi on 3. The only guy who's positive is tan. These two are both negatives. And then the last one is cos of 5 pi on 3. Sine and tan are both negative. And only cos is positive. Okay? And I guess, to be honest, even the radian measure, sometimes students have a hard time remembering the radian measure. As long as you can remember the angle measures, you can always find the radian measure by doing a conversion. Right? So the less you have to memorize, the better, or the less you think you have to memorize. So as John was saying, you only really have to only memorize a couple of values because these guys are just the flip, right? This is going to be 1/2, this is root 3 on 2, and this guy's just root 3. That's it. That's not so bad, right? Okay. Questions?